Hi, welcome to Dr. Raz, the Baking Chemist. Felt like doing a bit of DIY today, so I did some gardening, weather was cold, and I thought, let's get back to something I love, chemistry. Okay, so today, it's a 6 marker, it's a requested question as promised last week. It's not, even though it's a 6 marker question, it's not that difficult, okay? But a few students did get this wrong in the exams because they didn't read the question properly. Let's see what we can do. So cyclohexene is prepared by the dehydration of cyclohexanol using concentrated phosphoric acid. So cyclohexene, cyclohexanol, phosphoric acid as a catalyst. The structure of concentrated phosphoric acid is shown. So there is a structure. Identify the factors that influence the boiling points of each of the compounds. Identify the factors that influence the boiling points of each of the compounds in this reaction. Each of the compounds in this reaction. That means 1, 2, 3. Show how and explain why cyclohexene can be separated from the reaction mixture. So show how, state how and explain why cyclohexene can be separated from the reaction mixture. Can be separated. 6 marker, you can probably understand why. There's a lot of little questions in this one big question. Okay, now when I'm looking at this question, now in my head I'm already visualizing the structure of these compounds. Now if you don't know what they look like, I mean I know what they look like, so I'm already thinking along those lines, but if you don't hesitate to draw them out. And they don't have to be neat drawings. So I'm thinking cyclohexene. Okay, cyclohexene is like that. So it's like a benzene, but it's not. There you go, cyclohexene. It's prepared by the dehydration of cyclohexanol. And so they're going from cyclohexanol. So there's your cyclohexanol. Okay, cyclohexanol. And then, of course, phosphoric acid they've given you. So I'm immediately thinking, okay, cyclohexanol is that, cyclohexene is that, it's prepared. You don't need to know this particular part, but anyway, it's prepared from that using the catalyst. And then it says, identify the factors that influence the boiling points. Now, the first thing that students often get wrong is they start talking about covalent bonds. Remember, when you boil things, you don't break covalent bonds. It's intermolecular forces that you break. Okay, so I need to talk about intermolecular forces, not covalent bonds. If you start talking about covalent bonds in this question, you will start losing marks. Okay, so the first thing I'm going to answer is the first part of the question. Identify the factor that influence the boiling points of each of the compounds in this reaction. So factors, okay, identify factors. Well, factors. What kind of IMFs, intermolecular forces, has cyclohexene got? There's only 3 types of intermolecular forces that you need to know about. It's van der Waals forces, yeah, dipole-dipole, and hydrogen. Yeah, so van der Waals forces, dipole-dipole bonding, and hydrogen bonding. Well, do these have dipole-dipole? Do these have hydrogen bonding? No. The only type of intermolecular forces they have is van der Waals forces. So this, I'm going to put down van der, D-E-R, Waals. And the apostrophe is after the S, not the before, not before. Okay, so that's van der Waals forces. Okay, now obviously you should know immediately OH bond, hydrogen bonding. So this probably has, not probably, definitely has hydrogen bonding between the molecules. So that's the hydrogen bonding. Okay, and of course look at your phosphoric acid. Now I know we don't normally talk about phosphoric acid and intermolecular forces. But yeah, look, OH, definitely have to have hydrogen bonding. Yeah, not van der Waals. Well, actually, all molecules have van der Waals, but that's beside the point. The main bonding that affects these properties of this phosphoric acid is hydrogen bonding. So it will be hydrogen bonding. And you know what? I'll draw it here just so everything is... Okay, so that is also going to have hydrogen bonding. So identify the factors that influence the boiling point of each of the compounds in this reaction. So literally, I would say, cyclohexene, van der Waals forces. Cyclohexanol, hydrogen bonding. Phosphoric acid, It's hydrogen bonding. Okay, and then it says each of the compounds in this reaction, and then it says state how and explain. That's two questions in one. State how and explain why cyclohexene can be separated. Well, how? Well, van der Waals forces are the weakest forces. Yeah, these will be strong forces, strong IMFs, weak IMFs, and of course, so therefore, because these are weak forces, they'll have the lowest boiling point. And as soon as I'm talking about lowest boiling point, I'm talking about distillation. Yeah, you can talk about fractional distillation if you want, but distillation. So that means if I have a mixture of these and I want to separate this, if I distill it, this, yeah, will evaporate off first. Why? Because these are the weakest IMFs and therefore lowest boiling point, so this will boil off first. So the answer to that question, I'm going to move this up. The answer to that question is, so the answer to the part 2, how cyclohexene can be separated, is distillation. And then it says explain why. Yeah, so that's not the end. I need to explain why cyclohexene can be separated from the reaction mixture. Well, because, and this, even though I've said it there, I'll say distillation will separate off. You don't need to put this part down. I think that in itself will get you a mark, but will separate cyclohexene. Why? Because van der Waals forces, I've already said my full name there. Don't start using this, even though they might accept VDW as van der Waals forces. However, don't start just using that without at least explaining it once. So I've written it there ready. So, I don't mind now putting VDW. Yeah. In fact, if I want to be absolutely sure, I'll put VDW there, and now I can use VDW everywhere in this question. Okay. So VDW, van der Waals forces, are the weakest. Therefore, these break easily, and therefore cyclohexene boils off first. Boils off first. Okay, now I've written these out, I wrote these diagrams. What I probably would do in the exam is, this is for my own sort of benefit, so I would literally write down van der Waals cyclohexene contains van der Waals forces, cyclohexanol contains hydrogen bonding, phosphoric acid contains hydrogen bonding, distillation will separate cyclohexene, van der Waals forces are the weakest, yeah, therefore these break easily, and therefore cyclohexene boils off first. So I would actually literally write it down. But I guarantee you, even if you just put these down, this diagram, you will still get the marks, because I made it absolutely clear. Look, that's my cyclohexene. The only thing that they could ask you is, I've not labeled it, so do I know which one's cyclohexene and cyclohexanol? But I think that's going to be nickety, yeah. If they don't give you the marks based on that, yeah, I'll be surprised. But they've given you plenty of space there, right? You can write it down. So draw the diagrams for your own reference, and then write it down. Okay, you got 6 minutes to do it in. Okay, marks, literally, marks would be that 1 mark. Sorry, I better put a mark there. That 1 mark, that 1 mark, that 1 mark, because I've identified the factors that influence the boiling points, and this is going to be 1 mark. Distillation, 1 mark. Okay. Van der Waals forces are the weakest. Now, I've done it here as well, so I'll get the marks here or here, doesn't really matter. And of course, cyclohexene, these break easily, cyclohexane boils first. That'll be the 6th mark. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. 6 marks. It's a 6 marker, but it can be done in about 4 minutes, assuming you know these structures. Yeah, and as I say, if you don't know what these are, draw it. Yeah, cyclohexene, cyclohexanol. Okay, so have I identified the factors? Yes, I have. Which affect the boiling points. Have I stated how cyclohexene can be separated? Yes, I have. And have I actually explained why it can be separated? Yes, I have. So can you see? It's not a long question. Okay, it is a 6 marker, but it shouldn't take you long, assuming you know your structures. I said earlier, if you start using things like covalent bonds, remember in a boiling, when you're boiling things, it's these intermolecular forces that actually break. Yeah. It's these intermolecular forces that break, yeah, not these covalent bonds. If you start putting those down, if you start putting these covalent bonds down, you're going to start getting penalized, yeah? So make sure you're aware of this, please. Okay, well, I hope that was helpful. As I say, it was a requested question, so I hope that helped someone. So if you've got any organic questions or inorganic questions, or even physical questions, but I think I've got a lot of physical question videos. But anyway, if you've got any questions, any comments, please put them down. And if you've not subscribed yet, please subscribe and let me know how you're finding these videos. Okay, thank you very much. I'll see you next Wednesday. Bye.